Good evening, millennials. Today, we'll look at another LeetCode problem often asked in FAANG interview companies. So, this is the 39th problem in the LeetCode website, combination sum. So, let's read the problem, discuss the approach, and write the clean, elegant solution. So, combination sum. Given an array of distinct integers, okay, the arrays are numbers are distinct candidates and a target integer target. Return a list of all unique combination of candidates where the chosen numbers sum to target. You may return the combination in any order. Okay. The same number may be chosen from candidates and an unlimited number of times. Okay, this is important. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Okay. It is guaranteed that the number of unique combinations that sum up to the target is less than 150 combinations for the given input. Okay, so the maximum answer size can be 150. So let's look at the examples. Example 1, candidates were given the numbers 2, 3, 6 and 7 and the target is 7. We can get two outputs like 2, 2 and 3, which is the first one, or the 7. This output can be in any order. It can be 2, 3, 2 or 2, 2, 3 or 3, 2, 2, anything. Note that 2 can be used multiple times. Similarly, let's look at the example 2, 2, 3, 5 and the combination is 8. We can get 2, 2, 2, 2 or 2, 3, 3 or 5, 3 or 3, 5. So there are 3 combinations and you have to return an array of arrays. And for the third combination, the candidates is 2 but the target is lesser than the candidates. So you can't get anything, so you have to return an empty array. So we know that the candidate's length is less than 30 and the candidates of I is between 1 and 200, and it's given that all the elements of candidates are distinct, so there are no duplicates. So the first initial thought that must come to mind is when we can use the same number again and again to form a given sum, we need to do some kind of backtrack. So what we can do is we can take an element 2, find the target and subtract this element from it. So the remaining element is 5 and let's check whether we can create 5 from the remaining elements. And if we can, we just add the numbers to the current array and then continue the iteration. If we cannot, we just add again the same element and again continue the same process by backtracking. Okay, I think that must be clear. So for the first one, 2, 3, we first add 2, then we check for 3, 6, 7, it's not possible, so we again add 2, then we check in 3, 6, 7, then when 3 is added, we get this combination. Similarly for 3, we can check for again 2, 3, 6, 7 and so on. So this is the simple backtracking solution and the time constraints will fit because the candidate's length is within 1 to 30. Okay, so let's try to write a simple code. So we have to return a vector of vector answer. So I'll just declare a vector of vector int answer and I'll just return it. And before returning the answer, you need to backtrack for all the combinations. So what I'll do is I'll just send in the parameters and I'll just try to pick the parameters from here and then try to write the function definition. So the parameters are answer, in which we want to store, and then the candidates from which we will be backtracking the elements, and the target for which we need the sum. And for each combination I need to append it to the array. So each combination, what I mean by each combination is 2, 2, 3, 7 and so on. So during the initial backtrack, that will be an empty array. And then the index of the candidates. So first what element I need to send, then what element I need to send. So initially during the backtrack, the index will be 0. So whatever I have written below, I'll just try to write the function definition. So it's a void return type. Since we'll be adding the answer to the answer array, so I create a vector of vector int call by reference answer, then vector int candidates Then what do I mean by target is essentially the remaining sum for the current combination. So let me just rename it as remaining sum for clearer understanding. Then I need another vector int of current combination, and I need the index of the candidates which we are trying to do. So the initial base case for the recursion is when the remaining sum is less than 0, which means we have used up all the elements and the sum goes above it. That means we should not include this in our question. For example, if you use 2 and 3, you cannot form 7 with the remaining elements. That means the remaining sum will be 7 minus 2 plus 3. Therefore, you cannot form 2 from the remaining elements. So if the remaining sum is less than 0, you just return. You don't process further. If the remaining sum is 0, if the remaining sum is 0, which means you have found an element, you have found a combination. So what you do is answer dot push underscore back of the current combination. Remember, in the current combination we are having the combination which adds up to the given sum in this iteration of the backtrack. So you just do that, and else what do? You just iterate to the candidates and you try to backtrack. For int I equal to index, because we have to backtrack from that position which we have passed, I less than candidates dot size. You can just add a return here or no, doesn't matter, but still I plus plus I. Then what do I do is, to the current combination I add the current element of the backtrack, which is candidates of I. Then I try to backtrack with the remaining elements, which is essentially backtrack of answer, passing the same answer array, candidates. Even this is not going to change, but the remaining sum will be remaining sum minus candidates of I. This is because we have passed the candidates of I to the already we have added the candidates of I to the current combination, and the current combination is current combination because we have already pushed the candidates of I to it, and the index will be the ith index because we are currently iterating the ith element. And once we have checked with the current combination, we need to remove that element which we added to the current element of the combination, because it's said that we are allowed to use an element unlimited number of times. So this will return the correct answer, and when the remaining sum is 0, it'll always push back to the current combination to the answer vector of vectors. That way we'll receive the final answer vector of vectors. Okay, let me just do a simple improvement to my code. So I can just return the candidates.size here. It's not going to make much of a difference, but every time we are calculating candidates of size here, so I think that'll be redundant. So I can just I'm just trying to make the code faster, so I'm just sending this candidate size as another parameter. It depends on the language, sometimes it's faster or something, and even in this one we have to send it as a parameter. Yeah, so let's just dry run the code before we run it. I think it's an important step during major FAANG interviews. So void initially we are declaring a vector of vector int answer, and we are returning the answer, and we are forming a backtrack with 6 parameters: answer, candidates, remaining sum, current combination, index, and candidate size. And for the first one we pass answer, candidates, the target or the remaining sum, an empty array, current combination, and the index, which is v0, and candidate's size, which is candidates.size. If the remaining sum is 0, we just return. If the remaining sum is less than 0, we just return. There's no possibility of an answer. If the remaining sum is equal to 0, then we push back the combination to our answer array and then we return. Else we iterate from the index till the candidate size, and then we push the current to the current combination, we push that element, and then we backtrack again with answer, candidates, and now the target remaining sum will be remaining sum minus candidates of I, because we have pushed candidates of I, and current combination including the candidates of I, then the current index and the candidate size. Again, we need to pop it back because the same element can be used any number of times. Let me just run the code. Yeah, it passes for the given output. Let me just submit it and check. I'll just run it a few times to check if it passes. Yes, it passes. And that is the shortest code you can find on the internet. If you can write a more shorter, cleaner code or a better code, please leave it down in the comments below. Or if you have any doubts, please leave it in the comments and we'll reply back to you at the earliest. Thank you.